This is the answer to Chapter 2, problem number 19 from the Smith Organic Chemistry textbook. And in this problem, we're asked to explain the apparent contradiction that HBr is stronger than HCl. But HOCl is stronger than HOBr. And so in order to explain this, we'll first look at HBr and HCl. And so as you can see in HBr and HCl, these acids are of the type HZ, so the hydrogen is bonded directly to the halogen here. And so we can follow our acidity rules. That acidity is going to increase from left to right across the periodic table and from top to bottom down the columns of the periodic table. And so bromine is below chlorine. And so we would expect HBr to be the stronger acid here. So that makes sense. So when we look at HOCl and HOBr, what we see is that these are not really of the type HZ. So these are not HZ. The hydrogen is not bonded directly to the halogen here. So what we can do here is take a look at how these conjugate bases are going to look. So HOCl is going to dissociate into H plus and OCl minus. HBr, HOBr is going to dissociate into H plus and OBr minus. So, and I apologize, I should put that charge on the oxygen. So there we go, OBr minus. So the halogens here, the chlorine and the bromine, are actually exerting an inductive effect on the oxygen. So chlorine is more electronegative than bromine, and I'll put that over here in green. So, there we go. So chlorine is more electronegative than bromine. And because the chlorine is more electronegative, it's better able to stabilize the conjugate base here. Okay, and so remember, a more stable conjugate base equals a stronger acid. And so this isn't really a contradiction. It makes sense when we think about it in these terms. Chlorine is more electronegative than bromine, so chlorine is going to better stabilize the conjugate base here than bromine will. And so a more stable, stronger conjugate base equals a stronger acid. And so that explains why HOCl is a stronger acid than HOBr, even though HBr is a stronger acid than HCl. It's because we can't really make a direct comparison. We're comparing acids of the type HZ, where the acidity is going to increase along a row and down a column, versus these HO halogen acids, where we need to take the stability of the conjugate bases into account, and therefore the electronegativity of each halogen. And so that's the answer to chapter 2, problem number 19.